G'day, thanks for stopping by. Today I want to explore the solution to a problem that came up in a recent training course. The problem that needed solving was a post-sales support rate cost issue where the rate that was being charged for the post-sales support changed over time, and we were wanting to be able to analyze what impact that had on the total cost of support. Now, for some of you that have some experience in DAX, you might be thinking that a what if parameter would be a simple solution to this problem. However, the problem with the what if parameter is that the rate that we would put into a what if parameter applies to the entire calculation. And so what that means is if I want to change the rate in my what if parameter from 70 cents up to 80 cents, the change in the rate doesn't apply just to the date period when the rate changed. It applies across the entire calculation, including the historical data where the rate was 70 cents. So this is the question that we need to solve. We've got a situation where we've got three rates, and we have a rate of 0.7, so 70 cents, that is valid for any date that is before the 1st of July 2017. Then between the 1st of July 2017 and the 3rd of August 2018, the rate at 80 cents. And then after the 3rd of August 2018, the rate was increased again up to 90 cents. And so the question was, is it possible to create a helper table containing the rate information and get DAX to choose the correct rate to be applied to the calculation based on the current time period? And the good news is, it is absolutely possible. However, the what if parameter is not the solution that we need to use here, and we need to dig a little bit deeper to understand how to solve this problem. So I have a basic data model that I'm going to be working with. We've got a fairly similar construction. This has been put together based on the AdventureWorks dataset, so it is a very familiar dataset to many of you. But we have a calendar, customers, products, and sales territory here, and then each of those are connected down to my post-sales support table that's containing the details of customer interactions and how long it took to solve their post-sales issue. Now, in order to solve this rate problem, we need to start off by adding a new table to our data model that contains these rate values and these switchover dates. And so, just for the simplicity of this exercise, I'm going to do that by coming up to my home ribbon and clicking on the Enter Data button. When the Enter Data wizard opens up, I'm just going to create a simple table, and I will call this first column rate, and the second column I will call valid from. In the rate column, I'll start with a rate of 0.7, then we'll have a 0.8, and lastly a 0.9. And on valid from, so the 0.7 will be from the beginning of my reporting period, so that will be the 1st of January 2016. The 80 cents will be valid from the 1st of July 2017. And then the 90 cents will be valid from the 3rd of August 2018. And I'm going to call this table rate change. I'll go ahead and click load. So if I come back into my model view now, I can see, sure enough, there is the rate change table here, and it's floating off to the side. It has no relationships with the rest of the data model because it is a disconnected table. We've established that we can't solve this problem with a what if parameter because in that situation it would be applying whichever rate we choose to the entire data set. So how are we going to go about actually working with this disconnected table to pick up the valid rate for the time period that we need. For this, we're going to start with a measure that's going to take advantage of variable syntax. Now, if you're unfamiliar with variables, variables are very useful because they allow us to break complex problems into bite-sized pieces, and then we can verify those bite-sized pieces as we're going, just to make sure we're getting the right behavior out of the piece of the calculation that we're performing. So I'll just switch back over to my report view, and I'm going to find my post-sales support table. I will right-click, create a new measure, and this new measure I will call selected rate. Now, I'm going to go straight into using variables because I know this is going to be a complex problem and I need to do it over multiple stages. So the first variable I'm going to define is called this date. And this date will be the selected value of the calendar date. I will then return this date. Okay. So at the moment, the formula is capable of sensing what is the date that is in the visual, and based on the date that's in the visual, it's going to pick up that date and return it. So we're now able to detect the date being defined by the visual. The next step in this process is to understand how that date is going to impact the rate change table. We're going to have to write a table function in order to process the rate change table, but it's very difficult to actually get an understanding of what's happening in a virtual table. And so to make this easier to understand, I'm actually going to go over to my data view, and I'm going to apply a few physical filters in the data view to get an understanding of what happens to the table as we start to filter it based on particular dates. So in my data view, I will navigate to my rate change table, and looking at my rate change table here, if I click on the down arrow next to valid from and then hover my mouse over date filters, we can see that there is the option for a custom filter here. In the wizard, I want to set the custom filter to be is on or before, and then I want to choose a date that is going to be within the first rate threshold. So I will make that the 9th of March 2017. Click OK, and we can see the impact that that has had is it has filtered the rate change table down so that we're only getting one row being returned in the table. And that row happens to have a rate of 70 cents. If I go back into the valid from filter again, and this time I change the date to the 9th of July 2017 and click OK, we can see that the impact that that has had is that the table is now returning 2 rows. Now this is important because it highlights that in the next step of our calculation, we actually have to take 2 additional steps. We have to have a step that is going to apply these filters that we've just done with the custom filter settings. That will create a virtual table that will give us a table that contains 1 row, a table that contains 2 rows, or a table that contains 3 rows. But given that the table is going to have a different number of valid rates in it, we then have to have another step in our calculation that is able to identify the rate that we're most interested in based on the shape of the table at the time. And the solution to that will be a max. So if I'm looking at the max date of this table on the screen, I can see that that would pick up the 1st of July 2017 because that is the biggest date in the valid from. Okay, so the idea here is we're using the data view to help us understand this virtual table And understanding the virtual table then helps us understand what we need to do in order to process the DAX correctly. I will switch back to my report view now and find my selected rate. And we'll add in another variable. This variable will be the filtered table. The filtered table is just going to start with the filter function. We want it to step over the rate change table. And how do we want to define the new virtual filtered rate change table? For that, we want the rate change valid from column to be less than or equal to on or before this date. Remembering that this date is the date that we're sensing inside the visual. Now, we can't change the return in this case to filtered table, and the reason for that is because we're in a measure, and a measure returns scalar values. But this new variable I've created, filtered table, isn't a scalar value, it's a table value. And a table value contains columns and rows of data. So we can't actually test whether or not the filtered table is working, but that's why I went into the data view to have a look at understanding how the table will be processed. And we know that if it is on or before a particular date, then we get a different behavior. And so is on or before is the equivalent of is less than or equal to. And so now that we know we're processing the table correctly, we need another variable in here, and I will call this variable date to use. And this variable, we need to detect the maximum value of the valid from column of this new filtered table, this new virtual table. And so in order to do that, we need to use a calculate. So we need to calculate the max of the valid from, the rate change valid from column, and the filter that we want to apply, in this case, is a table filter, which is our filtered table variable. Close brackets, and this one we can return. Date to use. Okay. At this point, we can start to visualize our data and check that things are working the way we would expect. So I'm going to add in a table visual onto my page. And in my table visual, I am going to start with my calendar and choose my calendar date. And the calendar date just lists a series of dates from the 1st of July 2016 all the way through to the end of our reporting period. I'll also add my selected rate. And we can see here that from the beginning of our reporting period, we're picking up the rate as of the 1st of January 2016. But if I scroll far enough down until we get to July of 2017, we can see here on the 30th of June 2016, the valid from date was still the 1st of January 2016. But as of Saturday, the 1st of July 2017, the rate changed. We got a new valid from being returned. Remembering that our selected rate at this stage is returning the valid from result. So now that we've got our valid from date being picked up, the next step we need to achieve is what is the rate based on that valid from. I'll go back into my selected rate measure, and I'm going to add another variable, and this variable I will call rate to use. This will be a calculate as well, and this time I want to pick up the selected value of the rate change rate column when the rate change valid from equals the date to use. Change the return to return rate to use, and now we can see, once that formula has committed, we can see now the rate being switched over. Here on the 30th of June, the rate is still 70 cents, but as of the 1st of July 2017, the rate is now 80 cents. And if I was to scroll further down the table, we would find that when we get to the 3rd of August, the rate would change again, and on the 3rd of August, it would increase to 90 cents. We're now getting the behavior that we want out of our selected rate. So now we can go ahead and calculate our total cost of support. I'll right click on my post-sales support, new measure. This measure I will call total support cost, and this will be equal to the support minutes multiplied by the selected rate. We're talking cost here, so I will just give this currency formatting 0 decimal places, add it into my visual, and sure enough, we can see that on days where we've had post-sales service, we're getting a valid rate being returned. And if we were to actually look into that, we would see that the reason this value is $6 is because the rate has increased to 80 cents per minute. Okay, so total support cost is all looking good, but we're currently filtering our data by the date, and realistically, we're probably not going to be looking at it day by day. We're more likely to be wanting to know this information at a month or year level. So I'm just going to make some changes to my table. I'm going to take the date out of my table, and in my calendar, I'm going to put my calendar year and my calendar month name, and look what's happened to the table. The table has gone completely blank. There is no data being returned. What about if I right click on my month name and say show items with no data? We're now getting our calendar year and month name information, but the selected rate and the total support costs are both returning blank. The reason this is happening actually comes down to the selected value that we chose to use in our selected rate. Looking at the selected rate measure, I can see that the first value, this date, is being defined by the selected value of the calendar date. Now, providing I'm working at the date level, at the individual day level of my calendar, then this works fine. But the problem now is that I'm working at a different level of granularity. Now the smallest value that I'm looking at is a month, and on the month of July 2016 there were 31 days. Selected value only picks up the date when we're looking at one day at a time. As soon as we look at more than one day at a time, in this case 31 days, then selected value returns the alternate result. And if I just come back here to trigger the IntelliSense, we can see that when we've got the IntelliSense for selected value returns the value when there is only one value in the specified column. Otherwise, it returns the alternate result. The value I chose to specify was the calendar date. That was the column that I wanted selected value to return, but I did not define an alternate result. When we don't define an alternate result, the alternate result will be assumed to be blank. As a result, my selected rate is returning blanks all the way down the page. And that means when I go to my total support cost measure, I've got my support minutes multiplied by blank. A value multiplied by blank returns blank. And that's why my total support cost is now blank as well. So how am I going to overcome this granularity challenge? In order for that selected value of the calendar date to work, I need to ensure that even when I'm at the month or year level on my visual, that I still step through the calendar one day at a time. And the way I achieve that is by taking advantage of one of the X functions. The X functions, or iterating functions, step through a table of data one row at a time and perform whatever action you've asked them to perform one row at a time on that table. Now, in this case, I want to know the total support cost being the support minutes multiplied by the selected rate on the particular day. And then if I'm looking at the month, then I want all of the days of the month to be added together. And so in this case, the iterating function that I want to use, the x function that I want to use, is actually going to be a SUMX. Again, looking at the IntelliSense for the SUMX, the first parameter that we have to provide the SUMX is the table that we want to iterate over. In this case, I want to step through the calendar table. I want to step through the calendar table one row at a time, one day at a time, and for each row in that table, I want to perform the support minutes multiplied by the selected rate for that day. We can now see the total support cost is returning a valid support value. That's actually good enough to solve the problem at hand, which is what is the support cost going to be as the rate changes over time. We've addressed that problem, but for completeness, I want to explore the idea of actually solving this all inside a single calculation so that we don't need the selected rate interim measure at all. So I'm going to start off by just going back to my selected rate and copying the formula that's in the selected rate. I'll then go ahead and create a new measure. Total support cost 2 will equal everything that we've got in our selected rate measure, plus let's see what happens if we add in the total support cost variable at the end. So I will call this variable current row support, and that is just going to equal the SUMX of the calendar where our support minutes are multiplied by the rate to use, because we're trying to achieve it all inside one calculation now. And I will return the current row support. Again, once my measure is created, I'll give it currency formatting and 0 decimal places. When I add this into my table visual, we can see that we're getting this blank problem all over again. The issue this time is the fact that when we're working with a variable in DAX, a variable actually behaves more like a constant. Once a variable has been defined and calculated within the calculation, it is then fixed. So the issue here is that the rate to use that is being used in the calculation at the moment is based on the fact that we're creating a selected value of the calendar date up here. And this selected value of the calendar date is returning the alternate result because when we execute this variable, we're at the month level of the visual, and therefore we're getting 31 days or however many days there are in the month, and as a result we're getting the alternate result. So in order to make sure this date is actually picking up the correct date, then we actually need to wrap the entire calculation here. All of these variables need to be calculated inside that row by row analysis of the calendar. So the solution to this problem is to just wrap the entire thing inside the SUMX of the calendar, comma, then the expression is all of this. And in fact, now that we're stepping through the calendar one row at a time, we don't need selected value here anymore. We can actually just go straight for the calendar date, because when we're at one row of the calendar, one day of the calendar, there is only one date. So we don't need the selected value, we can just grab the date out of that calendar. We still need to perform all of the other values the same way, except the current row support now can just be the support minutes multiplied by the rate to use. And then the last thing we need to do is close the brackets on our SUMX, and this time when I press enter, we can see the calculation is being evaluated correctly. There's no need for you to go to the extent of doing the entire calculation in the single total support cost calculation if you don't want to. There's nothing wrong with doing the selected rate interim measure and then using that inside your total support cost. But I just wanted to illustrate for completeness that it is possible to do the entire calculation inside the single total support cost calculation, providing we understand that we need to step through the calendar table from the beginning, and each of our variables need to be picked up based on that day level of our calendar. I hope you enjoyed this lesson. If this is a problem that you ever need to solve, I hope you now have an idea of how to tackle it. Obviously, in this particular example, we did a simplistic version of the process, but where this technique can be really useful in a real-world scenario would be something like working out your total sales of products that have different prices depending on when they were sold, or perhaps different prices depending on where they were sold. As always, thanks for stopping by. I hope you enjoyed the video, and I look forward to seeing you again soon.